Hello everyone and welcome to my YouTube channel. Welcome to this series of LangGraph where we are learning the LangGraph in depth. So this is the part 2 of this particular series, and in the part 1 we have already covered the basics of LangGraph, and also we have built our first agentic AI framework with the help of LangGraph. So if you have missed that particular part, please go ahead and check out that. The link is available in the description below. So coming to the part 2, so in this particular video we are going to focus on understanding a conditional state graph in the LangGraph. So what is the conditional state graph? As its name suggests, conditional graph is nothing but we are going to add a conditional edge in the graph framework that we are going to build. And why exactly it is necessary? Because conditional edge is going to help us route the communications to the respective agent or nodes as per the requirement or as per the intent given by the user or as per the intent available in the user question. So we are going to build a smart conditional edge, which is going to take these dynamic decisions. So let's understand how exactly this is going to work. So first of all, let's understand what is the conditional graph state. So as you can see, conditional graph state allows workflow to dynamically decide which node to execute next based on the current output of a node, and which includes a decision making logic into the graph similar to if-else structure in programming. So it's like a normal if else condition that we generally use in our coding, but it is not a normal condition. It's a smart condition which allow workflow to dynamically decide which next node to call, and that too based on the output of a current node. So it understands the intent from the current output node, and then it decides which next node or tool to call based on the condition. That's where we are calling it as a conditional state. Now you might be thinking why it is necessary, because in our graph state that we are building, obviously whenever you are building a deep graph network, it becomes very much important for you to route the conversation so that you can reach to the correct point based on the user intent. Sometimes you no need to unnecessarily call the unnecessary tools, and that's where the conditional state takes care of skipping those particular edges or nodes which are not necessary while answering the user question. So let's understand some key points that are available in the conditional graph state. So the first key point is dynamic routing. As we already seen that conditional state allows workflow to branch to different nodes depending on the specific condition that we are defining into the state. For example, if we are building a conditional state, let's say this is our first node, this is let's say our agent, and this agent is capable to take a decision. Next, let's say it has access to one particular tool, that is our another agent, and then from that tool we are ending the conversation. So let's say this is our end node. Now, whenever this particular agent is calling this particular tool, it is extracting some information. It may be any custom tool, and based on that, then we are ending the conversation. But in some cases, you may need to call this particular tool. In that case, you want your agent to directly go ahead and end the conversation. Why to unnecessarily go ahead and call this particular tool? And that's where you can add this conditional age for this particular agent, and then that agent will take a dynamic decision whether to call that tool or not, and then end the conversation. So that is what is the dynamic routing nature. And as you can see, we have added one example. The agent is going to determine which tool to call, and it routes to that particular tool node. Otherwise it directly go ahead and generate the final response or divert the conversation to the or route the conversation to the response node, meaning unnecessarily you no need to hit to each and every node, because in actual scenario or in actual use cases there will be couple of nodes that you need to manage, and that's where your conditional edge help you. Then second one is the flexibility and adaptability, meaning the conditional edge enables the graph to handle multiple scenarios without hard coding linear sequences. You no need to hard code this particular logic. You no need to write any logic that is based on if else conditions, right? Because your agent is the LLM powered entity which is smart enough to take the decision, right? So this conditional edge is going to help the agent to take that particular conditional decision. Then it supports complex workflows with varying paths for different user input. Obviously, whenever you are building in real-time applications, there will be multiple complexity that you can add, or there will be multiple complex nodes that you need to build. And in order to build those deep graph network, definitely you need these conditional edges to take a call. Then next one we have is the modular design. Why modular design? Because each node performs a distinct function. So whatever these agents that we are adding as a node, each one is having its unique individual function, right? And we have added those nodes to perform that particular action or to generate that particular response based on the user question. As it is added in that way, right? If you are adding conditional age, you can go ahead and add a new edge, or you can add a new node as and when required, and you can add a condition. If that condition satisfies, then only go ahead and hit to that particular node, else go ahead and end the conversation. That way it gives you the modular design capability. You can add what and all nodes that are required for you to perform your task. Then next one we have is the implementation in graph. Let's see how exactly we can integrate that into the graph. So I think we missed this particular part. Conditional age controls how output of one node influence the next. Again, it is self-explanatory. Whenever you are adding multiple conditional states, it is going to route your conversation, and then based on the output of one node, it is going to decide which next node to call. That is going to save your time as well. Let's see how exactly you can integrate that into the language graph or LangGraph. So there is one function called add conditional age. If you remember in the last video, we have used the function add underscore age. This particular function we have added in order to build the age between these two nodes, right? Similarly, you can add a conditional age, add a conditional age. It is that simple, and you will be able to add the conditional age. And then the function evaluates the current state and returns the next node dynamically based on the intent. And that's how the graph execution continues. Now let's understand why conditional states are important. Obviously, so whenever you are building your actual projects or the real world examples, you will not see the graphs that are very linear. Like once this particular node is done, then you are going to call this node, then the next node, and then you are going to end the conversation. It's not going to be that easy. In your actual real-time scenarios, you will have to add a lot of conditional statements in order to reach to the end statement. There can be multiple graphs that you need to call, right? Because it is a graph structure, right? There can be a numerous number of paths that the conversation will flow through, and you need to define that particular conditional age in order to route the conversation to the accurate path. And that's where the conditional states are important. With our normal study examples, right, it doesn't require. You may see that, okay, how does it matters? But in your real examples, right, it does matter. And the conditional state makes the workflow intelligent, adaptive, and efficient. Intelligent because it is going to take the decision based on the intent. Second one, adaptive, meaning it is adaptive to the different nodes, right? Later on, you can go ahead and add any node as and when required. Then it is efficient because you have added conditional states. Each conversation will follow its respective path to reach the end. It no needs to go ahead and explore the another unnecessary paths while generating the end, right? Or while generating the final response. If it is going through all the nodes, it is going to take a lot of time. It is going to waste your token as well, because you are passing tokens to each node. Nodes may be LLM powered nodes, or it may be custom function. Unnecessarily, you don't want to call each node, and that's where it is efficient if you are adding the conditional state. Let's understand this with the help of very simple example. Okay, so we have the simple example where we are generating a conditional workflow for a customer support system. Now, in the customer support system, we need to identify the intent of user, and based on that, we need to route the query to respective tool or respective node. So in this case, this is our first node, which is the agent which is going to take decision, which is going to identify intent. And here you are adding a conditional state. Now, whenever you are adding this conditional state, what will happen? First of all, if the user question is related to the invoice or related to the billing, right, then this intent condition or intent node, based on the condition state, it should go ahead and call this particular billing support node, right? Because the user question is with respect to the billing or invoices, then you should call the billing query and not the any other these two queries. And once this query is called, you can go ahead and generate the final response and end the conversation. You no need to go ahead and call the technical support node or a frequently asked question node unnecessarily, right? If the user question is with respect to any technical query, if user is facing any technical issue, then it should go ahead and route the conversation to the technical support node and not to the billing query or general query. If the user question is related to the frequently asked questions, right, general query, then it should go ahead and route the conversation to this particular node. And this routing is going to take care based on the condition, because this condition we are going to define in such a way that it is going to take a decision at which particular node to divert the path or to divert the communication, and accordingly it is going to generate the final response and end the conversation. This is going to save your time as well. So I hope adding the conditional state is clear to you. If you have any question in this theoretical concept, please let me know in the comment section below. Now, enough of theory, let's go ahead and straight jump onto the exercise. So in the exercise, again, we are going to see a very beautiful example. We are going to build this particular agentic framework where user is going to ask a question. User question may be, let's say, so this is going to be basically a currency converter tool that we are building, and this currency converter tool is smart, which is taking smart decision based on the user intent. So let's say if the user question is what is the price of 10 USD dollar in INR, very simple, right? In Indian rupees, what's the price of 10 USD dollar? So that information we are going to pass it in the form of state. Now we have first agent which interacts with the user and extract the relevant detail. So you can see it is interacting with the user. Also it interacts with the fellow nodes, and then it extracts the relevant detail. Now as the question is with respect to the conversion of USD to INR, it knows that this agent knows that where we have added this particular conditional state where to go, it is going to call this particular node the currency converter tool, and this currency converter tool is going to actually convert these particular 10 USD to INR. It may be close to somewhere 880 or 881 rupees based on the current value that it based on the current USD rate that is going on. Then it is going to route that conversation to the final node, which is going to generate the response in human readable format, and then it is going to end the conversation. So that's the simple workflow that we are going to build. Now, if the user question is general question, what's the capital of France? Then that question first goes to this particular agent, and now this agent is smart enough to answer this particular question, right? There is no need to convert any currency. So this agent will return response as, let's say, Paris, and then now once we got that this particular answer, we no need to go to this particular tool. So in this case, it will go ahead and end the conversation directly, and that is going to save your time. You no need to waste your tokens in formatting this particular response or converting the currency. Even though if it goes to the currency converter, it will fail, because for currency converter there we are going to add few conditions, right? Like we need to pass this particular amount that you want to convert, plus we want to also mention that from which country to which from which currency to another currency that you need to convert. Those details you need to pass, and that agent, this node is going to collect. The agent is going to collect and pass it to the tool. Now for Paris, it's just the one word answer. It will go ahead and give that answer and end the conversation. You can route the conversation to the final response as well, and then it will generate the final response and end the conversation. For us to keep it simple, we have directly routed it to the end, and we'll see that how exactly this is going to work. So I hope the example is clear to you. So let's go ahead and start writing the code. Okay, so first of all, let's go ahead and install the dependencies. So we will be requiring LangGraph, obviously, because we are working on LangGraph. Then graph is in order to plot the state of graphs. Then LangChain, Google GenAI, because we are going to use a Google Gemini model, which is open source model, large language model, in order to save our cost as well. And also it is pretty much easy to use the open source model. Why to unnecessarily waste the money? So we'll be using the OpenAI model and LangChain in order to add the prompt capability or add the LLM capability. So as we know that LangGraph is a subset of LangChain, that's where all the LLM related questions, or sorry, all the LLM related dependencies that we need is going to be from the LangChain. So LangChain is going to help us build the large language model, and LangGraph is going to help us with building the agentic framework, right? So let's go ahead and start that. First of all, let's go ahead and import the dependencies. So for importing the dependencies, again, as I mentioned, from LangChain Google GenAI, we'll be importing Chat Google Generative AI class, and we have seen this in the previous video. This is basically to load the Gemini 1.5 Flash model that is available on the Google Gemini platform. Then prompts from LangChain in order to define the prompt template, and then from LangGraph we will be requiring state graph and end. As I mentioned, in the previous video, state graph is nothing but the directed graph, which meaning the graph with direction. So that we are going to build. And then this is for visualization. From ipython.display, we'll be importing image and display to display the graph, and the graph is in order to plot the graph again. So next one is, let's go ahead and add the API key. Let me go ahead and add the API key. So this is my API key. In the previous video, I told you how exactly you can go ahead and grab the API key. Let me show you that quickly. You can go to Google AI Studio, and from here, you can go ahead, log in with your Gmail account, and from here, you can go ahead and create the API key. Very simple. It may ask you to create a Google Cloud project. Please go ahead and create that. Again, it is free, and you'll be able to consume these APIs freely. So this is how we have imported the key. So I'm going to delete this particular key before uploading this video. So please make sure you are not sharing your API key with anyone. The next one is, as we have seen in the previous video as well, we need to initialize the Gemini large language model. Again, the initialization is very simple. It's just we need to call the chat Google Generative AI class, and from that we need to mention the model that we want to import and the temperature. So this is how we have defined the LLM. Okay. Okay, sorry, the import is not defined. So let me just execute that. Okay, you can see. The next one is we need to define the state. State is required for graph in order to tell the graph that what input and output that it is going to generate, or what state information that we need to pass. So as we mentioned here, right, state, what exactly it is? This state meaning what information that it needs to pass. So that state is nothing but user question and the response that is generated. So here you can see it will be agent response as well as user question. So that we need to define. And again, it is very simple. We just need to define this simple class. From typing, we have imported typedict just to define the type. And we have written this particular class where we need to define message and response, a very simple state that we have created. The next important part is defining the nodes. So let's see how exactly we can define the node. Now, defining node is the key task in this particular exercise. So first of all, let's go ahead and build these particular agents. So first we are going to build this node agent, then we are going to build this node tool, and finally the node agent for response, right? So we have 3 nodes and the end. And in the 3 node, for the second node is tool, not the agent. First and third are the agent. So we need to define in that particular fashion. So first of all, let's go ahead and start defining the first node. So again, it is very simple. We just need to write a Python function, and this function is nothing but our agent node, which is going to check if it's a currency conversion query. If yes, extract amount from currency to currency as plain text. We need those 3 details, right? Because whenever you are going to convert it, the currency, we need these 3 information. Then let me go ahead and add the prompt. So that was the doc string. This is the prompt. Again, I have written this particular prompt after doing couple of validations and testing. So this prompt should work for everyone. Where we are going to pass user question, whatever is the user question, you can see the user said, and this is the user question that we'll be passing. And if it's currency conversion, then we need to extract amount, the number which we want to convert, the currency from currency, meaning from which currency to what currency that we need to convert. So 3 letter we need to extract. To currency, again we need to extract 3 letter code, and reply in this particular format, amount equals to this number, from equals to this number, and to equal to this particular number. That's going to be the format. And if it's not a conversion, reply no tool and your natural response, right? This agent is just going to tell that whether to call a agent or not. If to call a agent, what are the parameters that it needs to pass to that particular tool, and why exactly it is written in this particular format. So I'll show you that. So let's start building the second node. Second node is our convert currency tool. So as you can see, it is a dynamic currency conversion using Frankfurter API. Now, what exactly is the Frankfurter API? Now, if you search Frankfurter, it is a website which converts or which gives the currency conversion rate, the latest currency conversion rate. If we are converting from USD to INR, it will give what's the dollar value currently with respect to the Indian rupee. So that information this particular website is going to give, and it is we are calling that API in order to grab the information, because we want real-time data. We are not hard coding anything, right? And your large language model may not have access to your live data, live dollar value, right? Or the exchange rate between dollar and INR. It may not have that. And that's where this Frankfurter API is going to help us extract that particular information. So how exactly this works? So let me show you that quickly. So this is the website that we have, Frankfurter API, where we need to pass amount, from, and to. So let's define these three parameters first. Let's say to we need to convert to INR. That's what we have defined. From we need to define from USD, and then we have amount. Let's say amount is, for example, let's say 1. We want to convert $1 from USD to INR, and let's see what exactly it is going to generate the response. Okay, this thing request is not defined. Let's import request. Okay, it has generated the response. Let's see what is there in the response. Okay, it is returning 200. So we need to convert this response into the JSON format. So response.json. So if you see that, you can see it is giving amount amount $1, base is USD, date 1909. So you can see the latest date 1909-2025. Then rates is 88.16, meaning $1 is equivalent to 88.16 rupees as of this particular date. Meaning it is the latest data, right? Now your large language model may not have that information, but with this particular tool, we are going to add that. And that's the API that we have written. Now this API, we need to add it into the currency converter tool. So let's go ahead and add that. Okay. So we have added this information. Now here we need to add a amount, then from, and then to currency. So this information we are extracting it from the state. Now state is nothing but the output that this particular agent node is going to return. That's the information from first agent node. Let me show you if you are confused. For this particular node, state is nothing but user question. But for this particular node, state is nothing but user question and the answer generated by this particular node. And what this node is going to generate? It is going to generate this particular number, the from currency to currency. These three parameters that it is going to pass. So what we have done, we have extracted these three parameter. Default value we have given 1. If it could not find this particular amount, then it will pick default value. So these three parameter we have defined, and then we have called this particular URL API that we just saw. And if response is status code 200, meaning if response is success, we are going to convert that to JSONs. And from that, we are going to extract these three values. And this is going to be our raw response, where we are going to add amount from currency equals to this particular rate and to currency. Else, it is going to return the error. And this is the final response that state the message that is asked by the user, and the response is this particular raw response. So that's the response it is going to generate. Now you might be confused for this. So let me go ahead and complete this particular agent node tool first. So that will become very clear to you. Now we have added this particular chain to our agent node. This chain is nothing but we are adding LLM capability. You can see prompt and LLM. So this prompt and the LLM that we have defined. Which LLM? This large language model, that is Gemini 1.5 Flash. And then we are going to generate the output from chain.invoke. We are going to pass user question and the state message. Now from state, we are going to pick message. Now you get that right. From for here, we are just passing the message from state. But what the state is going to return, this state always return message and response. But whenever user is asking question, that response will be null. Only message will be there. Just like we discussed here. For this particular node or agent, there is going to be only user message. There will not be any response. Response this agent is going to add into that and transfer it to the or move it to the next edge, next node. So that's what we are extracting, and we are stripping that. And then if output starts with amount equals to, then it is going to split it based on equal to, and it is going to return this particular response, meaning it is just checking this output. Whenever it is going to extract that particular information, right, in this output, what it will be based on user question, this prompt that we have given, it is going to extract these three information in this particular format. So if this amount and equal to is available, just one condition we have added, then it is going to return these information into the state. We can see for state message, it has added the message. The response, it has mentioned use tool. So this will give the feasibility to use tool or to call the tool. And then this is the final response that it is going to generate. So now you can see state message, user message, and response. It is going to add this particular response, the output, and then this particular final response. Sorry. So that's the final response, meaning it has added state as well as the response. And if amount equals to is not available, then it is going to return simple state message and the normal output that the particular agent is going to return with no tool, meaning it is going to add no tool, right? Because if the question is general, we no need to go ahead and call the tool. So very simple and easy function that we have written. Two nodes we have defined, agent node and currency conversion node. Now the third agent or third node that we are going to add is just to generate the final response. So this agent, which is just going to generate the response in human readable format. So let me go ahead and add that particular node. And this node is again very simple. So you can see we have added response agent. Again, we are passing state, and the task of this particular agent is to refine the response from currency tool into human readable text. Very simple. And then we have added a prompt. Here is a currency conversion result. Please convert it into a clear human readable sentence. Very simple. And then we are invoking a again large language model we are using in order to refine this particular response into human readable format. That's it. And we are all set. Let me comment this. Right? And now the next step is to build the graph. Now, as we have defined these agents, now we need to build these connections. So first, we need to start the conversation and define these three nodes and the end. And we need to define the edges between that, right? So let's go ahead and do that. So for that, first of all, let's go ahead and import the state graph and end that we have already imported. So no need to import that again. So let's go ahead and build the graph. First of all, state graph, we have imported it from the LangGraph, and we need to pass and it is going to accept a dictionary. And this is the workflow. So we are generating the workflow out of this state graph, and that workflow is nothing but we have created the workflow now, LangGraph workflow with the help of state graph. And in that workflow, we just need to add node. With workflow.add node, we can go ahead and add the node. The node name is agent, and this agent node function that we have given, this one. Agent node, very simple. We have added first node, then second we have added convert currency tool. This is the name, and then the convert currency, this function, simple. And third one, response agent and the response agent node. See, these three functions we have added as a node, out of which first and last one is the agent. You can see agent, and the middle one is the currency tool. Then now we can go ahead and define the condition. So the condition is very simple. Let me just go ahead and add the condition. We have written a function called route condition. State response, if it is mentioned use tool, then it is going to return currency converter tool, meaning it needs to call that currency converter tool, else end. Very, very simple condition that we have written. If the response is use tool, as you can see here, we have given that in the response, if it starts with amount equals to, meaning if it is with respect to the currency converter, then in the response add use tool. Now here, if it is going to add the use tool, obviously this condition it is going to check, and if it is checking this, then it is going to call the currency converter tool. If that use tool is not there, then it is going to end the conversation. No need to go into that two unnecessary nodes. That's the conditional edge that we have added. Now let's go ahead and add that particular conditional edge. So adding the conditional edge, this is just the condition that we have defined. Now this is how you can add the conditional edge. Workflow.add conditional edge. That's what we have seen earlier, right? So if you see here, we have mentioned that add conditional edge. We have added the conditional edge now. With the help of add conditional edge, agent to route condition. This route condition is nothing but this tool. Now your first agent, this one, has the capability to decide where to route it, and then it has two edges. First edge, it has two edges. First edge is currency converter tool to currency converter tool. That's the edge that we have added, and second one is the end, meaning ending the conversation. This is the name of the age, and this is the actual age. From agent, it is going to call the, or it is going to route to the currency converter tool, and else it is going to call the end. So that's how we have defined the conditional age. Very simple. Now we will go ahead and just add the normal ages that are there that we need to define. The next age is like, again, currency converter tool to response agent, and then from response agent to end. So those are the other two ages that we have defined. So our workflow is complete. I'll show you that how exactly it looks like. And again, entry point we need to set. From where we are going to start the conversation is with agent, right? Now let's go ahead and compile this particular workflow. Now compiling again is very easy. Workflow.compile. Now this complete workflow is ready. Let's go ahead and execute that. And now I'll go ahead and show you how exactly that graph looks like. So again, showing the graph is very simple. Again, we use this draw mermaid graph, which help us to plot the graph. So you can see we are getting this mermaid code. Mermaid code is very simple actually, meaning it adds the code in the format of where you can add the code in normal natural language, and then it plots that. If you want to see the example, let me show you that. So behind this particular graph, I have added a mermaid code. So let me show you that. You can see this is the mermaid code that I have. Start in this particular square bracket we need to define. Then this is the intent node, we need to define that, and then we need to define the direction, how exactly it is going to call. So with the help of this simple natural language, you need to write that, and then it generates this particular mermaid graph. So that's what our LangGraph is going to generate, and that's what we are going to store into mermaid code. And that mermaid code we are just displaying with the help of ipython.display. So let's go ahead and plot that. Okay, you can see how beautifully it has written this particular chart. So first we are starting the conversation with agent node, then we have currency converter tool, and then we have response agent, and ending the conversation. But as we have added a conditional age, you can see it is denoting it with the help of dotted line. So this agent either can go to this currency converter tool, or it can directly end the conversation. That is what we initially decided. That's how we have built the workflow as well. And as the workflow is ready, now the last part, which is very beautiful, we just need to go ahead and execute it. Let's go ahead and execute that. So now it's time to test. And again, testing is very simple. Let me go ahead and add this. So in the message, input message, we need to write what is the price of 10 USD to INR. And then we are going to invoke app, and we need to pass that input. So this app that we have built here, we just need to invoke that, and we need to pass the input. So let's go ahead and print that. Let's see. It should now give us the conversion. Okay, you can see what is the price of 10 USD to INR. That was the user question, and response it has generated 10 US dollar is equal to 881.60 Indian rupees, because $1 is equivalent to 88.16. So yeah, this is working, and this is the state. You can see in this format it is generating the response. If you remember the state that we have defined here, it is generating the message and response, and it is a type of dictionary. So in the dictionary format, it has written this particular response. You can see message is the key, this is the value of user question, response is the key, and that's the value, right? Let's go ahead and test it for one more example. Now I will change the way of writing this. Hey, I want to know the price of, let's say, 8 USD to INR. And here, let's say if I'm just mentioning that US dollar to Indian rupees, let's not mention these details as well. As we have LLM, it should go ahead and understand that, okay, here we are talking about US dollar, and that we want to convert to Indian rupees. Let's see whether it is working or not. Okay, you can see, hey, I want to know the price of 8 US dollar to Indian rupees. Response 8 US dollar is equivalent to 705.28 Indian rupees. It's working as expected, right? Now, user question can be anything. The point that I mentioned, right, it is working based on the intent. It is not a hard logic that we have given. The condition is not a hard condition or if else loop that we have added. It is taking the decision based on the user intent or the intent available in user question. So that's how beautifully it is working. Let's go ahead and test it for some another use case where it should go ahead and directly end the conversation, which is not related to currency conversion. Let's say the user is asking question, what is the capital of India? Now it should directly give the response as the Delhi and end the conversation. You can see, hey, what is the capital of India? The response, the capital of India is New Delhi. It is not routing the conversation tool, right? So that's how beautiful it is working. You can ask now any question, your LLM will go ahead and generate that. Let's say if I'm asking question, simple, let's say, hey, what's your thought on the agentic AI using LangGraph? A generic question. Let's see. Now it should generate the response. You can see, hey, what's your thought on agentic AI using LangGraph? I don't have thoughts on opinion as I am an AI, but I can tell you that LangGraph is knowledge graph technology that could potentially be used to build agentic AI system, but I don't have access to specific detail about any such projects because it is a generic information that it is giving. So yeah, uh, in a summary, we have studied the conditional graph, why it is important. We have studied the key points. Also we have studied also we have seen a very good example, simple examples with which we understood this particular use case, and then we have solved a currency conversion tool use case in order to understand or in order to experiment how exactly this particular conditional edge is working. So yeah, I would rate it 10 out of 10 for the conditional edge, because when I was reading through this document, even I was thinking that the conditional edge, it may be a hard-coded logic that we need to integrate, but no, it is totally working on the intent, as you have already seen that. So yeah, I hope you like this particular video, and we will be continuing this particular series. We will be learning more about the LangGraph, and we are going to unfold each and every part of LangGraph, and also we are going to see an end-to-end real-time use cases at the end. So please stay tuned for the upcoming videos. And if you like this particular video, please like the video, subscribe to my YouTube channel, and share it with your friends. And the playlist is available in the description below. Please go ahead and check out that. Thank you so much, and I'll see you soon in the next video. Thank you.